So we were doing chain rule in the last class, and we did some examples on it. So let's do another example, which is example number 2. Example number 2 is differentiate. There are two parts of the example 2. The part A is y equals to sine x whole square, and the part B is y equals to sine square x. So let's do each part. Example number 2. Y equals to sine x square. Y equals to
This is the chain rule, right?
Sorry?
Chain rule, right?
Yes, we are going to continue with the chain rule.
Okay.
This is the outer function. This is the inner function. What does chain rule says that we have to differentiate the outer function first, and then we have to differentiate the inner function. So using a chain rule, let's differentiate the outer function. Outer function is sine. So when we differentiate,
So minus cosine.
Yeah,
No, it's cosine, just cosine.
Yeah, cosine x square, right?
Yeah.
And then we will be differentiating the inner function, that is x square. So it will be cos x square, and when we will differentiate the x square, it will be
Cosine 2x.
It will be
Cosine 2x.
Okay. So 2x cosine x whole square.
Okay. So there are two separate parts.
Yes.
Okay.
And
I thought the final answer will be cosine x 2x. That's all.
No, that's the outer function that we differentiated, and then there is an inner function as well that needs to be differentiated. So we differentiated that x square part, and we got 2x cosine x square. Is it clear?
Okay. Yeah. It's clear now.
Okay. Now let's do this one. Can we write sine square x as sine x whole square x?
What do you mean?
Like if we have x square, can I write it like this, taking the square at the whole term, just like the way that's sine x, and taking the square on the whole term, whole sine x. So this is our outer function. I mean, the square function is outer. Squaring is outer function. And the sine x, which is an inner function. Okay, if we differentiate it, first we have to take the derivative of the outer function, which is square term, and that we will be applying the power rule. That is, we have to take the power first, and then we have to subtract the power -1 from it, and then we have to take the derivative of inner function, which is sine x. Is it clear?
Okay, so now it's sine x bracket square. Yeah. So first we do the power rule. So we take the 2 down, and then 2 minus 1. So it becomes just 2. Yeah. And then so now it become 2 sine x. Okay, just 2 sine x. Okay, so this will become 2 sine x.
And then we have,
and then the inner function will be cosine. So 2 sine x multiplied by cosine.
Yes, that's the answer.
Cosine x also. Okay.
2 sine x. Is it clear?
Yeah, it's clear. Can we do one more example?
Yeah, if we, there are 3 to 4 examples on the channel. We'll be doing all. There's another identity used to simplify it. That trigonometry identity is called double angle formula. Double angle formula.
Okay.
Which is sine 2x equals to 2 sine x cosine x. So instead of writing 2 sine x cosine x, we can write sine 2x. And that's the answer.
Okay, wait. So this is a rule, right?
Which this is an identity. Just like the identity just like the identity that we already studied, like 1 plus tan square x is equals to sec square x. That was also an identity.
Can you, like, if you can, like, make a paper with all the identities so I can have a look at them all together?
I will send you by today the list of all the identities that we will be using. Just remind me that I have to send you. I will be sending you today.
Okay, so here we're saying that sine 2x is the same as 2 sine cosine x.
Yes.
So if we saw 2 sine cosine x, we can take it as sine 2x.
Yeah.
Okay, and so now let's the initial answer was 2 sine cosine x. Will this be wrong?
You can write this answer. It will be okay. If you can simplify it or apply the identity, then that will be okay as well.
Okay.
Yeah.
Understood.
So we did this example, part B and part A. Now let's do this one, example number 3, which is x cube minus 1 whole power 100.
What will the question be? Using chain rule or just like differentiate
they
or what?
They will just be asking you that you have to differentiate it, and that's up to you which formula, which rule using. Like an example, they just have asked you that you have to differentiate that function. Now you have now it's up to you that which identity, which rule that you are going to use to differentiate it. So differentiate y equals to x cube minus 1 whole power 100. That was our example number 3. Can you see that the first identity that we can apply here is in power rule?
Yeah.
Okay, so first that identity will be applied, and then the second identity, the second rule, not identity, that we will apply it is power rule or chain rule. Why chain rule? Because there is one function. There is one function that is power of 100, but there is another function inside that function that is x cube minus 1. We have to differentiate that again as well. Is it clear? So these two rules will be used to take the derivative of this question. So y dash equals to, first we have to apply the power rule. What does power rule says? Power first, and then we have to take the minus 1 from the power.
So the whole 100 will be the outer rule, right?
Yeah.
Okay.
And then we have to differentiate again the inner function, that is x cube minus 1. Is it clear? First power rule and then the chain rule.
Okay, so the inside one will become just 3x squared, right? That's all.
Yeah, if you differentiate it, then it will be 3x squared, and then we have to simplify this part. 100 x cube minus 199. Is it clear? That's the whole answer.
Yeah. But that's it. خلاص, no need to go more.
No, if you want, just we can multiply it with 3 with 100. It will be 300 x squared, and then x cube minus 199. Is it clear?
Yeah, but why 300? Why 300?
We multiplied 3 with this 100. So it will be 300 x squared minus x cube minus 1 power 99. Why
don't we multiply it by the first bracket, which is 100 multiplied by x cube minus 1?
You mean x cube minus 1 power 99?
Yeah, why didn't we multiply by this one and instead we multiply by the other one?
Can you please form your question again?
Can you go back to the other screen?
Oh, yes, sir. Yeah.
How can I write on the screen?
Let me just give you an I think I have given you an option to annotate it.
Okay, anyway, this y equals 100 bracket x cube minus 1 power of 99, right? Why didn't we apply the?
You are asking about
why didn't we multiply this 100 by the first bracket instead of the second one?
We can't it now. This is 100 constant. Right. This is constant 100, and then this is in a power term. I need to first simplify it, then I can multiply it by 100. I don't need to simplify that much, the power 99 equation to get my answer. I'm just keeping it as it is, and I'm just multiplying 100 with 3x squared. It's just like this. It's just like this. If I have x squared, okay, 3x squared, and I have some term x plus 1, there's in a power 3, okay? And here it is x5. So rather than simplifying this whole term, I can just multiply 3x squared with x5. It will be 3x7, and just keeping this as it is. I don't need to simplify it. Even it's easier to simplify. It's not a human. The human brain can simplify it.
Yeah. Okay.
So we are just keeping it as it is. Why it's not erasable? Anyway, is this question clear to you?
Yes.
Okay. Okay, let's do example number 4, which is f of x equals to 1 divided by cube root of x squared plus x plus 1. f of x is equals to 1 divided by cube root of
I cannot see your screen.
Yeah, sure. 1.
Okay.
That was the question. F of x equals to 1 divided by cube root of x squared plus x plus 1. Okay, if we have to differentiate it, it means we have to find out f dash of x. If we see here that can we simplify our function like this? F of x is equals to 1 divided by x squared plus x plus 1, and removing the square root
3 over 1.
1 over 3. Okay, and taking 1 over 3 to the numerator side, it will be x squared plus x plus 1 minus 1 over 3. Is it clear so far?
Yeah.
Okay. So looking at the function, what rules do you think that we can apply in order to take the derivative of the function?
Power rule.
Okay, power rule. And the second rule will be?
Addition rule. That's it, I think.
We can't apply the chain rule?
But there is no big power number.
Big power number means?
Like 100 or 50 or 25.
No, the power rule is chain rule is not applied for that. See, if minus 1 over 3, the cube root part is an outer function, okay, and there is an inner function as well, that is x squared plus
okay,
1.
okay.
Then for that we have to
Understood.
apply the chain rule. And yes, the addition rule is like the terms are additive, so we have to take the derivative of each term individually. So taking the derivative of it, f dash of x equals to power first, x square plus x plus 1 minus 1 over cube, minus 1 from the power, and then the derivative of the inner function, which is x square plus x plus 1. Is it clear?
Yeah.
Okay. So f dash of x equals to minus 1 over 3. It will be
2x.
X squared plus x, and what would be the power? Minus 4 over 3. And the derivative of inner function is the
2x.
derivative of x squared is 2x. Okay,
plus
and the
1.
Okay. Now we just have taken the derivative and have just simplified it. So f dash of x equals to 2x plus 1 minus minus 1 over 3, 2x plus 1. Can we take minus 4 over 3 power to the denominator side to make it positive coefficient or positive power? So it will be x squared plus x plus 1 power 4 over 3. This is the answer. Is it clear?
Yes. It's a bit more difficult, but it's clear until now.
Sorry?
It's a bit more difficult, but it's clear.
Yeah, you just need to practice it. The more you practice, the more rules will be clear to you. You will be very quick that which rule to be used. Well, let's get back to the book. We did example number 4. Now we have to move on to the example number 5. Example number 5 is g of t equals to t minus t over 2t plus 1 power 9. Okay, let's do this one. t minus 2 over 2t plus 1 whole power 9. Okay, let's first understand which rules will be used. Looking at the function, can you tell me which functions that's which rules that we can use to take the derivative of function?
Is the power rule first.
Oh, okay.
Okay, I think division rule also.
Yes, the quotient rule.
Quotient rule, okay, and chain rule also we can use.
Yes.
Oh no, I chain rule because there's outer and inner. That's it, right?
Yes, that's it. These three rules will be used. So f dash of
and all these questions, the question is just differentiate, right?
Yes, find the derivative of the function or the differentiate the function, something like that.
Okay.
Okay,
This is +1 or -1? The question.
It is +1, 2t plus 1, t minus 2 over 2t plus 1. Okay, applying the power rule, power first, and then t minus 2 over 2t plus 1 minus 1 from the power, so it will be 8. Right?
Yeah, -1.
And then taking the derivative of the inner function, that was t minus 2 over 2t plus 1. So that is f dash of t. F dash of t equals to 9 t minus 2 over 2t plus 1 whole power 8. Applying the power rule or quotient rule, it will be, this is our g of x. Sorry, this is our f of x.
The bottom is g of x.
Yeah. So keeping the g of x as it is and taking the derivative of f of x will be, the derivative of f of x means the derivative of t minus 2 will be
1.
Okay. Minus sign of the formula, keeping the t minus 2 as it is, and the derivative of g of x will be
I think x only. I mean t.
No.
I'm confused. I forgot.
The function is g. It's actually f of t and g of t. Okay. So the g of t is 2t plus 1. 2t plus 1. And if we differentiate
the 1 will get cancelled.
Yeah, okay. And 2 is constant. 2 is constant that we can take out, and then we take the derivative of t. So it will.
Derivative of t is 1.
Yeah. So the answer will be.
So it's going to be 2 only.
Yeah.
Okay, I got confused.
And then the whole power of g of t. 2t plus 1 whole power. Nine t minus 2 over t plus 1, 2t plus 1 whole power 8. It will be 2t plus 1 minus sign of the formula, and we multiply the 2 with t minus 2, it will be
2t minus 4.
Yes. Over. Can I just multiply minus sign in outer minus sign with the whole function?
Yeah, it's going to be the same thing, right?
No. If we multiply the minus sign with the function, then it will be plus.
It become t plus 2, right? Minus 2.
Yeah, minus 2t plus 4. right?
Wait, I got lost. Can you please repeat?
Yeah. When I multiply 2t minus 4 minus 2, and then there's a minus sign outside the function. So it will be minus 2t and minus minus plus 4.
Plus.
Is it clear?
Yeah, okay.
So 2t plus 1 whole square. Can we cancel out something? 2t is cancel out with 2t.
Yeah.
Okay, what we are left with 5.
Why don't we cancel the 2t at the bottom also?
You mean this 2t of 2t plus 1?
No one with denominator.
Yeah, this 2t
Like,
plus 1.
we cancel the top two. Why not the bottom also? The other part, the next part.
This part, right?
Yeah. Why don't we cancel the 2t at the here? We cancel 2t and then 2t again. Why don't we cancel this 2t?
We can't cancel it.
Okay, it's minus. Okay, it's minus. Okay, I thought that. Okay, never mind.
Okay, and now
Understood.
9 multiplied by 5 is 45, right? And then 45 divided by 2t plus 1 whole square multiplied with t minus 2 over 2t plus 1 whole power 8. Is it clear? This is the answer.
Okay. Clear.
And they in the book they have just simplified it further by one step, that it's 45 and 2t plus 1 over 2t plus 1 whole square multiply with, can we write 8 with each term? Right? Can we do it? Hello? Hello?
Hello. Yes. I can. My headphone cut off.
Okay.
Okay, go ahead.
Okay. So 45 t minus 2 whole power 8 divided by, the base is same. Can we add the power?
Yes.
So it will be 10. This is a simplified derivative of f dash of.
Okay. Understood.
Okay, let's get back to the book. Okay, we did example number 5 and we got this. Now let's do example number 6, which is differentiate y equals to 2x plus 1 whole power 5 multiplied with x cube minus 1 minus x plus 1 whole power 4. This is example number 6. Y equals to 2x plus 1 whole power 5 d over dx of x cube minus x plus 1 whole power 4. This is the question. Y equals to 2x plus 1 whole power 5, x cube minus x plus 1 whole power 4. And we have to differentiate it. So the very first rule that will be applicable here is it product rule?
It's a multiplication rule, yes.
Multiplication rule. Product rule. And the second rule that will be power rule. Right?
Yeah.
And then there is
also chain rule.
Yeah, now we'll be using the chain rule because we have inner functions as well. Is it clear?
Yes.
Okay. So y dash will be keeping, this is our f of x. This whole is our g of x. Keeping f of x.
So which rules?
We are
which
going
rules do we do in order?
We are going to apply product rule first, which is f of x g dash of x plus g of x f dash of x. Do you remember this rule?
Yeah.
Okay. So keeping f of x as yes.
In the earlier questions, we used to apply power rule first. Like here, you see directly we did 9.
Yeah, the power was on the whole term. If the question was something like that, if we actually can apply the quotient rule first. If we can divide our power among the numerator and denominator. You can, if you can write your function like this, then you can apply the quotient rule first and then the power rule second.
Okay.
So power 2x plus 1 whole power 5, taking the derivative of x cube minus x plus 1 whole power 5. There's a plus sign of the formula. Keeping g of x as it is, taking the derivative of 2x plus 5, 2x plus 1 whole power 5. Is it clear?
Clear.
Y dash will be 2x plus 1 whole power 5. Okay, now the power rule will be used here. Power first, and then if we then minus 1 from the power, so it will be x cube minus x plus 1 power 3, right?
Yeah.
And then taking the derivative of inner function, applying the chain rule here. Is it clear?
Yes.
Okay. And then plus sign x cube minus 1 x plus 1 whole power 4. Applying the power rule, power first, 2x plus 1 power minus 1 from the power, so it becomes 4. And now taking the derivative of inner function, applying the chain rule, so it will be 2x plus 1. Is it clear?
Yeah.
Two x plus 1 whole power 5, and it will be 4x cube minus x plus 1 whole power cube, and taking the derivative of this function will be 3x square minus 1, right? Okay, and then we have a plus sign, x cube minus x plus 1 whole power 4, 5 2x plus 1 whole power 4. Okay, And now taking the derivative of the inside function, it will be 2x plus 1. Taking the derivative of 2x plus 1 will be
2.
x plus 1 power 5. 4 times 3x square minus 1 x square minus x plus 1 whole power 2. I just interchanged this function with this function. That doesn't matter. Plus sign, and multiplying 2 with 5 will be 10. 2x plus 1 whole power 4 x cube minus x plus 1 whole power 5. Is it clear?
The last step, not so much.
Okay, I just multiplied 2x plus 1 with the whole term. Okay, so 2x plus 1 was as it is, and multiplying 4 with 3x square minus 1, 4, 3x square minus 1, and then keep writing this x cube minus x plus 1 whole power cube, and then there's a plus sign. Multiplying 5 with 2, it becomes 10, and then 2x plus 1 power 4 multiplied with x cube minus x plus 1 power 4. Is it clear?
Okay. Yeah.
Okay, let me check the answer. In the book, I think they might have simplified it further. That's the book answer. No, we have got the same. For 2x plus 1 power 5 x cube minus power cube and 3x square minus 1, yes, plus 5 times 2 is 10 power 4 power 4. Yeah, it's till this part, we have got the same answer. And then noticing that each term has a common factor. Okay. They have taken the common 2x plus 1 power 4. This is common, right? And this term is common, which is x cube minus x plus 1 power cube. Is there anything else common? It's 4 here, it's 10 here. So we can take common 2. So the function will be 2 times 4, 2 goes into 4 by 2 times. And 2x plus 1 power 4 is taken out. So inside is left 2x plus 1 only. And this whole term is taken out. And the left is 3x square minus 1. Is it clear?
Yeah.
Okay. Then there's a plus sign. 2 goes into 10 by 5 times. And they have taken 2x plus 1 power 4 common. And inside is left x cube minus x plus 1 only. Is it clear?
Yeah.
Okay. Now just simplifying inside 2x plus 1 power 4 x cube minus x plus 1 whole power 3. The simplifying it, 2 times 3 is 6x cube plus 3x square minus 2x minus 1. Is it clear? Minus 5.
It's clear, but it's confusing.
Which part?
Like, like so many, like So many steps.
Yeah, this question is actually lengthy, but once you drew it yourself on your copy, then you will get an idea that how to move further.
Like, how long does this question take? Like, if it is a quiz, how long do they expect us to take on this question? 5 minutes? 3 minutes?
5 to 10 minutes.
Like, if you were doing it alone without explaining to me, how long will it take you?
For me, it will be taking like 5 minutes. The derivative part was easy, but we have to simplify it as well. So it will be taking 5 minutes.
Okay.
2x plus 1 whole power 4. X cube minus x plus 1 whole power cube. And then multiplying the whole thing with 2. So it will be 12x cube 6x square minus 4x minus 2 plus 5x cube minus 5x plus 5. Is it clear so far?
Yeah.
2 multiplied with 2x plus 1 power 4, x cube minus x plus 1 whole power cube. 12x cube, 5x cube will be 17, x cube minus 6x square will be as it is, plus 6x square. Minus 4x minus 5x will be minus 9x, minus 2 plus 5 will be plus 3. Is it clear?
Yeah.
That's the answer after simplification. That's what we have got. Okay, doing example number 7. This is an exponential function that we have already studied. That what are the derivatives of exponential function? So y equals, and the question is that we have to differentiate y equals to e raised to the power sine x. Example number 7. Do you remember the exponential functions?
Ex is 1. No, ax is ex. So
Yeah.
e sine x is the same?
Derivative of e sine x will be as it is, but there is another function, right? Inner function, that is sine x. So we have to take the derivative of sine x, applying the chain rule here.
Okay, just one question. One question. If they said, let's say, differentiate e to the power of x, the answer will directly be ex, right?
Yes, the derivative of ex, the derivative of ex is
ex.
Okay, but if there's any other function other than x, like if there's a 2x, then we have to take the derivative of 2x as well. Then there was a sine x, then there was a sine x, then we have to take the derivative of sine x again. That is our inner function. Is it clear?
Okay. Yes.
So y dash equals to e, and the derivative of sine x is cosine x.
Cosine x.
So cosine x e raised to the power sine x. Is it clear?
Yes.
Let's get back to the book.
In this case, which one is the outer, which one is the inner?
Should I get back to the screen?
Yeah.
Okay.
Oh, no need. Okay. Okay. So which one is the outer, which one is the inner? E or sine x?
Yeah. E is the outer function and sine x is the inner function.
Okay.
Okay. There are 2 more questions on the chain rule. So the question is sine, cosine, tan x. Here will be applicable twice. The chain rule will be applicable in this example. Let's do this question. Y equals to sine cos tan. This is the question that is given. So for the sine, cosine and tan x is the inner function.
Yes.
For the cosine, tan x is the inner function.
Yes.
Okay. So we will be applying the chain rule twice, like this. Taking the derivative of the outer function. The outer function derivative will be sine x, derivative will be cos, and the inner function will be as it is, cos tan x. Right?
Okay, and then we take the inner function.
Okay, the inner function.
No, we take the outer function of tan.
Yeah, the outer function is now cos tan x.
So it's minus sine x. Minus sine tan x.
Yes. Cos tan x. Now the derivative of is minus sine tan x. Right?
And now
Now
again.
the tan x is again inner function. So it will be tan x.
Tan is minus sec, right?
Tan x is sec square x, yes.
Sec square x?
Yes.
Okay.
So it will be cos inside function cos into tan x. Can we take the minus sign outside? Because it's multiplying only. So sine tan x, and the derivative of tan x is sec square x. That's the answer.
Can we simplify further?
I don't think so, but we can simplify it.
Okay.
It's not further simplifiable. Let's check the answer from the book. It's not further simplifiable. And notice that we have used the chain rule twice. Was this question clear to you?
Yeah, this question was clear.
Okay. If, for example, if we have the function like this, the question is the same. Okay. Sine cos tan, and then again side the tan x, we have tan 2x. Can you tell me what will be your answer?
Again, please.
The question was previously tan x only, right? Now I changed the question to keeping everything same. I changed the tan x to tan 2x. Now can you tell me what would be the answer?
Tan 2x. It'll be. We just do one more time chain rule, right?
Yes.
Okay.
So it will be tan 2x here. It will be tan 2x here. It will be tan 2x here, right?
Yeah.
And then tan 2x here. But everything will be the same. We just when we differentiate tan 2x, okay, and then it will be sec square 2x, and then again there is a 2x function. We have to differentiate again. So when we differentiate the inner function 2x, the derivative will be 2.
Yes.
Okay. So how many inner functions are there? Doesn't matter. You have to differentiate them again and again. Is it clear?
Yes. Clear.
Okay, let's do example number 9. we have to take the derivative of e sec 3 theta example number 9, y equals to e sec 3 theta. That was our example number 9.
This is sec 30, right?
Yes, this is sec 3 theta. Okay, if we differentiate it, can you tell me what will be the differentiation? What will be the derivative of the function?
I don't know how to do with theta. Or is it the same thing?
Can you please repeat your question?
With theta, it's the same thing?
Yes, it's just like x. Now we are differentiating the function dy with respect to theta. So far we were differentiating our functions with respect to x. So that's the same thing. If the function is in terms of x, then we have to differentiate with respect to x. If the function is in terms of theta, sec theta or any, then we have to differentiate it with respect to theta. Is it clear? Now our function is in terms of theta, so we have to differentiate with respect to theta.
So first step is to differentiate e, which will be e sec 3 theta. Okay, and then the second differentiation will be to differentiate sec. But then what's for sec?
Oh, okay. We have to differentiate sec 3 theta, right? The derivative of sec 3 theta is sec 3 theta and tan 3 theta. So e sec 3 theta is the derivative of sec x is sec x into tan x. So sec 3 theta into tan 3 theta. Is it clear?
Yes.
And there's again a chain rule that we have to apply. Right?
Why? Okay, so this is different. I thought it was with like it's like one function with sec.
The derivative of sec 3 theta was sec 3 theta into tan 3 theta. Now the inner function as well, 3 theta, that is the inner function. So we have to differentiate it again. Is it clear?
Okay, so yeah, what's the derivative for 3 theta? 3, right?
Yes.
3, yeah, 3,
yes.
just 3.
So
theta, we consider it as x.
See, 3 theta, now we are differentiating our function with respect to theta. So taking 3 out and differentiating theta with respect to theta, so it will be 1. So the answer will be 3.
Okay. Okay.
Okay, the answer is 3. So I'm taking 3 outside. E sec 3 theta and sec 3 theta multiplied with tan 3 theta. Is it clear?
Yes.
Let's check the answer. We have got the same thing. This is exercise 3.4. You can do these questions 7 dash from 7 question number 7 to 46. You can do some of these questions in order to get a better idea of these rules. Okay, the next topic is 3.5 implicit differentiation. That is again an important topic. So let's get back to here. Okay, so far we were studying the functions that were like this: y equals to sine x, y equals to e raised to the power x, y equals to something. The questions were like in the functions were like in this form, right? That y equals to sine x, sine theta, y equals to ex. The y was separate, and whatever was on the right side of the function, it was in terms of purely in terms of x, and the y was separate. Y equals to x sine x, right? So far we have studied such kind of functions, and then we applied the differentiation rules. What if we have the functions in terms of like this? It's hard for us to differentiate the function one minute. It's hard for us to differentiate the function, like taking the y square separate, and then 25 minus x square, and then now taking the whole square root, and then it will be y equals to 25 minus x square. And now taking the derivative, because now the function is purely in terms of x on the right hand side of the equation, and on the left hand side is only y. Now our functions is in this form. So far that what we have studied. Is it clear?
In the middle of your explaining, yeah. my laptop lagged. So can you please repeat again?
Yeah, sure. I was saying that so far we have studied such kind of function that where x was separated, y was separated. If the function comes in this form, that x square plus y square is equals to 25, then how we will differentiate it? Okay, for that we have to just take our y squares on, have to separate our x and y terms. So taking x square that side, it will be 25 minus x square, right?
Yes.
We need only y, so we'll be taking the square root. It will be 25 minus x square whole square root. Is it clear?
Yeah.
But sometimes it will be hard to simplify. Sometimes the functions will be like very hard to differentiate y and x separately. Let's get back to the book and have a look. What are those functions which are hard to simplify? Like
and this is the final answer?
No. We are just simplifying it. I was just giving you example that what is implicit differentiation. What is the advantage of implicit differentiation? So these functions are easy to differentiate, right?
Yeah.
We already studied that y is separate. We have to just differentiate the right side of the equation. Now we can't differentiate the function. The function is on the left hand side of the equation. The function is in terms of both x and y.
Yes.
Okay. And again, x cube plus y cube plus 6xy is equal to 6xy. Again, the function is in both x and y terms. So for this, what we have to do, we implicitly differentiate them. Let's do the example number 1, and I explained you what does that mean. So the example number 1 is x square plus y square is equal to 25. All the time the function will not be simplifiable like this. All the time we can't separate x and y. For that, if we can't simplify it, then we apply the implicit derivative. we derivate the right side of the equation and the left side of the equation with respect to x. This will be x square plus y square, and taking the derivative of right side. Its right side will be 0 because it's constant term. Right? What will be the derivative of x square?
2x. No, just 2. 2x, sorry.
Okay. Okay, now the function is like this, right? For d over y square is a constant term, just like (25), but the 25 we make it 0. For that, we will be applying the power rule. Power first, -1 from the power, it will be 2y, right? Is it clear so far?
Yes.
Okay, and then applying the chain rule, we will be differentiating the inner function, that will be dy over dx. If the function is like this, d over dx y cube, okay, then we applying the power rule, it will be 3y square, right? Power first, -1 from the power becomes 3y square, and then applying the power rule, it will be dy over dx. Is it clear?
That's clear, but can we do one more example, because
we will be doing more examples on it. It's just the first exam that I was making you understand what is the advantage of different implicit derivative. So the derivative of x square was 2x, and the derivative of y square with respect to x was 2y dy over dx. At the end of what we need only dy over dx, right?
Yeah.
2x is equals to taking 2y dy by dx, that side of the equation, it will be minus 2y dy by dx, right?
I'm lost. In this question, I'm a bit lost.
Which part you're not getting it? Can you please say it?
Like, why, like, let's say in this case, why was, where did we bring this minus 2y, and then why, how can we, like, everything.
Okay. Let me just erase it out, everything. Okay, the question was that we have to find out in example 1, the function is this, x square plus y square is equals to 25. You have to find out dy by dx, okay? Dy by dx means we have to find the derivative. So, differentiating the equation with respect to x. We are differentiating both sides of the equation. Okay. So the derivative of 25 will be 0. Okay.
And then it'll be 2y plus y2 plus 2y plus 2u.
2x will be the derivative of
2x plus 2,
2y, and then dy by dx, right? What we need dy by dx, the answer in terms of dy by dx. So 2x as it is, if I take the 2y dy by dx, that side of the equation, it will be minus because it's positive here. If we take it that
minus 2y,
it will be minus 2y by 2y dy by dx. Can I cancel 2 on both sides of the equation?
Yes.
Okay. So dy by dx will be minus x over y. Right? X equals to y, dy by dx. Taking y that side, so it will be minus x over y.
Yeah, okay.
Okay, so we got our first part, which says we have to find out dy by dx. And the second part was that we have to find out the equation of a tangent to the circle. The equation of circle is this at the point 3, 4. So we have to find out the equation of a tangent line. You know that the equation of a tangent line. For a tangent line, what we need? We need a slope. And second thing, we need a point. Right?
Yes.
We have got the slope. That is our slope, right? In dy over dx is slope. Our slope is dy over dx is minus y over x, and we have given a point. Point is given to us is 3, 4, right?
Yes.
3, 4. So slope is dy by dx minus y over x. Y is 4. This is our x. This is our y. Right? Okay. So our y is 4, and our x is 3, right? So what is the slope is minus 4 over 3. And the equation of a line is y minus y1 equals to m x minus x1. y1 is 4 equals to m is minus 4 over 3, right?
And then 3 minus?
X minus 3. This is x1 comma y1.
Okay.
Okay. Y equals to minus 4 over 3x minus minus plus. Can we cancel out this 3 and we are left up with only 3 or 4? Is it clear?
Why do we cancel?
Okay. Y equals to multiplying minus 4 over 3 with the whole equation minus 4 over 3x. Multiply minus with minus, it will be plus 4 over 3 multiplied with this 3. This 3 will be cancelled out.
Okay, yes.
And then there is minus sign, which minus 4, it will be plus 4 in this side of the equation. So the equation becomes minus 4 over 3x plus 8. Okay, let's check from the book that we have got the correct equation. That was the slope. Okay, they have further simplified it. Can we simplify our equation and write it in this form? 3y is equals to minus 4x plus 24.
How come?
Wait 1 minute. We have in the answer they have 25, but we have got 24. Y minus 4 is equals to minus 3 over 4. Oh, wait. The slope was minus x over y. and by mistake I wrote here y over x. Okay, it's minus x over y, and then it was minus x over y. X is 3, y is 4. The slope is minus 3 over 4. Is it clear?
Again, please.
What is this question clear to you so far?
Yeah, everything was clear, yeah. Okay. But then how come we got 24 and we got 25?
Yeah, because I made the mistake here in writing the slope. In the actual, the slope was minus x over y. We got it correct, but when I was writing again the slope formula, I wrote minus y over x instead of minus x over y.
Okay.
So I got the slope value incorrect. So I'm just correcting it now here. So minus 3 over 4x, and then minus plus 9 over 4. 9 over 4 is 25 by 4. Okay, so what I did, I got the slope minus 3 over 4 because x was 3, y was 4, so I got minus 3 over 4, and I substituted till this line, I substituted my values, and then I multiplied it. Y is equals to minus 3 over 4, and then minus plus 3 minus 3 multiplied with 3 will be 9 divided by 4, and taking the minus that side of the equation, it would be plus 4. Is it clear?
Yeah.
Okay, and then 4 times 4 will be, I simplified it. So it will be 4 times 4, 16 plus 9, 25 divided by 4. Is it clear?
Yes.
And it's minus 3 by 4. Is this question clear to you so far?
Yes.
Okay. Now y equals to minus 3x plus 25 divided by 4. Because denominator is same, so we can write it like this. And multiplying the 4 with y. 4y equals to minus 3x plus 25. So it becomes 3x plus 4y is equals to 25. This is the answer in the book. Even if we complete our solution at this point, it's okay. Even if we don't multiply the 4 with y and then write the answer in this form. Three x plus 4y is equals to 25. This is the solution. So, okay, let's do the example number 2. The question is that we have to find y dash if x cube plus y cube is equals to 6xy. X cube plus y cube is equals to 6xy. Okay. Again, we can't simplify our y separately. We can't write our function in terms of y and then the function. right? It will be hard if we first simplify it in terms of y and then we differentiate it. So we can directly differentiate it as the function is it given to us. So differentiating the right side and left side of the equation with respect to x cubed plus y cubed is equals to differentiating the 6xy with respect to x. Is it clear to you so far?
Yeah.
Okay. The derivative of x cubed will be 3x squared.
X cubed. Yeah, 3x squared.
Oh, so yeah, x raised to the power 3. X cubed, the derivative will be 3x squared, power first, and then taking the minus 1 from the power. Okay. Now we have to differentiate y cubed with respect to x.
So 3y squared.
3y squared, and then dy by dx, right? 3y squared dy by dx is equals to, again,
Now, on which one do we put dy by dx? The first or the second, or doesn't matter?
Because we are applying the chain rule here. We have to differentiate the inner function as well. So that's what we call.
I mean, like, why we didn't put dy over dx on 3x squared?
Okay, d over dx of 3x squared of x cube. Okay, applying the power rule here, it will be 3x squared, right? If you differentiate inner x with respect to x, it will be 1, right?
Yeah.
That's why it's only 3x squared. But in this case, it can't be 1. We have to write it as it is, y over dx. Is it
Don't
clear?
understand the difference between them.
Yes, because we are differentiating the y with respect to x, and that's what we are getting. Yes.
Okay. No, I understood.
Okay, now taking the 6 common, that's constant term, d over dx of x into y. Now there are two functions, x and y, both are multiplying. So we'll be applying the product rule. Okay. X as it is, taking the derivative of y with respect to x, plus sign of the form term. Y as it is, and taking the derivative of x with respect to x. Is it clear?
Yeah.
Okay. 3x squared plus 3y squared dy by dx is equals to, multiplying 6 with the whole, 6x dy by dx will be as it is, plus this will be equals to 1.
Yeah.
Right? And multiplying 6 with y, so it will be 6y. Now we are solving for what? We are solving for dy by dx. That's what we have asked in the question, but we have to find y dash. Right? So can we separate our y dash terms aside and the other terms aside, like 3x squared, taking minus plus 6y, that side of the equation it will be minus 6y.
Yeah, we have to change it.
Yeah, 6x dy by dx, and taking this, that side of the equation it will be minus 3y squared dy by dx. Is it clear?
Yeah.
Now it will be 3x squared minus 6y is equals to, taking common dy by dx, it will be 6x minus 3y squared, right? Y dash or dy by dx is equals to 3x squared minus 6y divided by 6x minus 3y squared. Is this question clear to you?
Yes.
Okay. Okay, let's get back to the book. Can we simplify it a little more? Like, if we take the 3 common, then we are left with x square minus 2y, and 3 common from the denominator, it will be 2x minus y square. So it will be x square minus 2y, 2x minus y square. Is it clear? Okay, the question was, we have done part A. And in the part B, it's asking that we have to find out the tangent of, we find the tangent to the folium of Descartes x cube plus y cube is equals to 6xy at the point of 3, 3. We have to find the equation of a tangent line at the point 3, 3. And the point was 3, 3. We have find out, we have in the part A, we got slope, right? X square minus 2y divided by 2x minus y square. If we put our point x comma y, which is 3, 3 into the slope equation, we'll be getting 3 whole square minus 2 into 3 divided by 2 multiplies 3 minus 3 by 3 whole square, right? Is it clear to you so far?
Yeah.
Okay. So 9 minus 6, 6 minus 9. So it will be 3 minus 3 and the slope is minus 1.
Okay, slope is minus 1. And then now we have to write the equation of the line.
Yeah, now we have to just put the points on the slope into the equation. So y minus y1 is equals to slope is minus 1, x minus x1, which is 3. So y equals to minus x plus 3 that side, it will be y equals to minus x plus 6. Let me check.
Why we got the minus 3? Why minus 3?
Talking about this line.
Yeah, how come? Where do we get the minus 3 from?
Oh, okay. Y minus y1 is equals to mx minus x1. That's the equation of the line. We know that what are the x1, y1, 3, 3. Slope was minus 1. So it becomes y minus 3, minus 1, x minus 3. Is it clear?
Okay. Yeah. Understood. It's clear.
Okay, let's check the answer. The answer is x plus y equals to 6. Okay. Can we take our x that side of the equation? It will be plus x plus y equals to 6.
Yes.
Even the equation in this form is also acceptable. So let's get back to the book. Okay, the part C is, at what point in the first quadrant is the tangent line horizontal? Okay, tangent line horizontal means that the slope will be 0 if the line is horizontal tangent line, right? tangent line is horizontal if y dash is 0. Using the expression that we got in part 1, if we, okay, let's do it again. Okay, y dash was x square minus 2y and 2x minus y squared. X square minus 2y, cross multiplying it will be 0. Right? Taking 2y that side of the equation, it will be x square is equals to 2x, x square is equals to 2y. Okay. So what will be the value of y? Half x square. Is it clear?
Yes. Okay. Yes. And this is the final answer.
No, we have to find out the point in the first quadrant that where the tangent is horizontal tangent, where the tangent is horizontal. In the part C, that at what point in the first quadrant is the tangent line horizontal. So we have to find out the point x comma y. We have got the point y. Now we have to find out the point x. For that, we have to put the y equals to half x square into our first equation, that was x cube plus y cube is equals to 6x square, 6xy. X cube plus y cube is equals to 6xy. This was the equation that was given to us initially in this equation to find out the value of y, to find the value of x. Is it clear?
Yeah.
Okay, x cube plus y is half x squared cube. 6xy is half x squared. It will be 2 goes into 6 by 3 times. It will be 3x3 on the right side of the equation. Is it clear?
Yeah, it's clear, but I'm getting lost a bit with the steps. But I think if I practice, I'll be better.
Yeah. X cube plus half. Okay. The cube root of half will be 1/8, right?
Cube root of half? How come?
I mean the cube, not cube root. Cube of half will be 1 and 2 times 3. 2 raised to the power 3 is 8. Is it clear?
Yes.
Okay. And then 2 times 3 will be 6. X cube are the same terms. 1/8 x raised to the power 6 is equals to 3 minus 1 will be 2x cube, right?
Yeah.
Okay. And multiplying 8 with this, so 8 x power raised to the power 6 will be 16x cube. Can we cancel out x cube? It will be 16. X cube is equals to 16.
Yeah.
Okay. So the cube root of 16 is, using a calculator, it is, do you have a calculator with you?
Yes.
Okay, can you find out its cube root?
Wait, how do I find this out?
Yeah, sure. Press shift hex There will be a decimal, hexadecimal, binary, octa in your calculator.
Okay, so I put 3 and then 16.
Yes.
Yeah, I got 2.51.
Yes. 2.5. Okay, the x coordinate is 2.51 and the y is y was half x square. Okay. As we have got x, we just put the value of x into this and then multiply by half. So it will be 3.174, right? Have you got the same?
2.51, yeah.
3.1748.
Okay.
Did you get it?
Yeah, but as I said, I need some practice.
Yeah, you need to practice it. So at this point, the tangent will be horizontal. There will be horizontal tangent in the first quadrant. So this is the answer that we have got, 2.51 and 3.1748. Is it clear?
Yes.
Okay. From the next session, we will be continuing with example number 3. So let's end the session here. I think it has been 1 hour 14 minutes.
Yeah, approximately.
Yeah. Okay. Okay. So let's end it here. And okay, one thing, can we do the class tomorrow in the morning instead of this time?
Like what time in the morning?
10 to 11. Okay, my 10 will be your 9 o'clock, right? So if your 10 o'clock will be my 11 o'clock.
Now my time is 4:35.
Okay, it's 5:35 here. So if I take
okay, so you're 1 hour ahead.
Yeah, if I take the class at 11 to 12 in Pakistani time, so it will be 10 to 11 there.
10 to 11.
Yeah.
No, I cannot actually tomorrow. I cannot because I have to go for the prayer and we have to go early, so I cannot tomorrow.
So tomorrow, which time you will be available to the class? At the same time?
Yeah, I prefer the same time. But if you cannot, and then okay, we won't do a session tomorrow. If you can't this time, we won't do a session tomorrow, no problem. And then we'll do on Saturday.
Okay. And what about after 2? Or I mean after 1? Will you be available that
tomorrow?
Yeah, tomorrow after 1. 1 to 2
No,
Pakistan.
after 1, like what time? After 1, like what time?
After 1, like 1:30 to 2:30.
No, I can't. Tomorrow, and except for, like tomorrow, I'm only empty. I'm only free in the evening, like 4, 5, 6, like that. But in the morning, I cannot.
Okay. Okay, I will actually let you know, because I think we can't take the class like 4 to 5. We can actually delay it like for 1 hour or 2 hours. I will actually let you know. Is it okay for you? Okay.
Yeah. Okay. Okay.
So, but it means after in the evening, after evening, you are free at any time, right?
Yes.
Okay.
Okay, but before, just let me know in case.
Yeah, sure. I will let you know.
Okay. Thank you.
Thank you.